And that concludes our weather report. Back to you, Felipe.
Thank you, Manny. Our team has been researching a developing story about a company called TT Corp, which has developed methods to find the areas of everyday shapes in life. Everyone's been wondering whether these formulas are really going to work, so we're going to go to John Berlin, who's going to show us how to find the area of many different common shapes.
Yes, Felipe, this is a huge story that everyone has been talking about. Everyone really wants to know if TT Corp's formulas really work. Let's first examine how to find the area of a parallelogram. I have a piece of bread here as a perfect example of a parallelogram. According to TT Corp's formulas, to find the area of a parallelogram, we first find the base, which I pre-measured out to be 8 millimeters. Then we measure the height, which I pre-measured to come out at 7.5 millimeters. We then take these two variables, multiply them together to get an area of 60 millimeters.
Oh! Well, hi, John. That is truly amazing. Who knew that a formula could work that well? Well, now we're going to go to Larry Hausenberg for the next shape.
Yes, Felipe, I'm now here with a rare special of a shape known as a triangle. It consists of 3 sides, 3 points, or edges. Thanks to TT Core, we can find the area of this shape by measuring the base and the height of the triangle. The height of the slice of pizza is 18 millimeters. And the base is 7 millimeters. Now we can multiply those two numbers and divide it by 2. According to my handy dandy calculator, the slice of pizza is 63 square millimeters. Now back to, crikeys, look over there! It's a wild circle. Now a circle is a little more difficult to find the area of. TT Core has come up with a brilliant formula to solve our problem. The formula to find the area is pi r squared. Pi is a number that is infinite, but can be represented by, but isn't the first 3 digits are 3.14. R is the radius of the circle, which is the case of 8.4 millimeters. So now we square our number, which comes to 72.25, and finally we multiply our number by pi. Get an area of 226 square millimeters. Now we're going back to John, who is going to show us a shape called a regular polygon.
Thank you, Larry. I'm here to show you how to mathematically solve a regular polygon. This cup is a perfect example of a regular polygon. It is in the shape of an octagon. To solve the area for this octagon, we need to find the perimeter and the apothem. I have measured, and the perimeter comes out to be 20 millimeters, and the apothem comes out to be 2.8 millimeters. We now need to multiply these two numbers together to get a number of 56 millimeters. Then we finally divide our product by 2 to get an area of 28 square millimeters for this cup. Well, now we are going to go to, hey, what is happening?
Where am I? What? Why is everything squares? What happened? Where am I? Oh. 1 block equals 1 meter. Well, how about I find the area of this giant square? Now, the square formula is quite simple. All we need to do is find the base of the square, because all 4 sides of the square are equal, which means if this is 8, then this side is 8, and that side is 8, and that side is 8. So now all we have to do is multiply 8 times 8 to get a total area of 64 blocks, or in this case, according to the sign, 1 meter. So we have 64 meters of blocks. Now, the real question, how do I get out of here?
Well, while John finds his way out of that alternate dimension, let's go to Larry, who's going to show us how to find the area of a rectangle.
Yes, John, I'm here with and that shape is a rectangle. One example is, hey, I'm shooting some right now, a gun package. A gun package is a perfect example of a rectangle. Finding the area of a rectangle is very similar to a square. All we have to do is find the length and the width of the rectangle. The gun package has a length of 7.5 millimeters and a width of 6 millimeters. Now we multiply our length and width to get an area of 45 square millimeters.
Awesome. Okay, now Larry is going to go out back to show us how to find the area of another shape, the elusive trapezoid.
I'm out in the studio courtyard tracking a very dangerous elusive trapezoid. These are rare to see in the wild. To find the area of the trapezoid, we need to find the length of both bases and the height of the shape. I don't want to get close, so I'll guesstimate that the longer base, about 28 millimeters, and the shoulder base to be about 17 millimeters. The height looks to be around 16 millimeters, so now we multiply 28 and 17 to get 476. Now we divide this by 2, and then multiply our quotient by 16 to get an area of 3,808 square millimeters. Okay, now I'm going to try to get close while it's sleeping. It's very dangerous, so it's important that we are very, very quiet.
Achoo!
Oh no, it's wait! Run! Ah!
Well, that's too bad for Larry. Let's hope he is alright. On the bright side, I found my way out of an alternate dimension. So, how about I show you guys how to find the area of a rhombus. I have here a couple of Lego pieces that form a perfect rhombus, with 2 obtuse angles and 2 acute angles. According to TT Corp's formulas, we need to find the height and the width of the rhombus. I have pre-measured the length to be about 16 millimeters and the height to be about 12 millimeters. We take these 2 variables and multiply them together to get 192. Now I divide this by 2 to get an area of 96 square millimeters. Now, we're going to head back to Felipe.
Thank you, John and Larry, for showing us just how well TT Corp's formulas really work. That concludes our latest news report for the evening and our puppy segment. Join us next week as we talk about the recent attacks from the ISIS terrorists in the Upper South.